Hello, everyone. In all this time that I've been teaching, I've been doing a lot of IGCSE and GCSE prep, and I've noticed that a lot of the tricks that they involve that are used in the IGCSE and GCSE also appear in GMAT problems. Especially in terms of percentages and fractions. I thought I would make a quick video on GMAT questions, and I'd give you an idea about how I'd go about solving them. This is my foray into selling myself for GMAT and GRE tutoring as well, in case you guys are interested. So yeah, let's take a look at the first question and let's see how it goes. So the first one, it says it gives you membership of organization X. Before I start, clearly GMAT is very time intensive. On average, every question in the math section, not the data section, but the quant reasoning section should be done within about, on average, 2 minutes. Of course, that doesn't mean that you take 2 minutes per question, right? Some questions will get done in 30 seconds. Some will take about 2 to 3 minutes or 3.5 minutes. So you need to obviously utilize your time and optimize it in the most effective way. All right. Without further ado, here's the first question. It says membership of organization X in 1988. So there's five different types of members. It says, according to the table above, the number of fellows was approximately what percent? The number of fellows was approximately what percent of the total membership? Okay, well, the number of fellows, you've already got the number of fellows to be 9209, and the total organization, ORG. If you obviously you're not allowed a calculator, so you will need to kind of, approximate these. So if you look at 35 plus 9, that's 44,000. This is another 700, so let's call it 45,000, right? 45,000 plus about 28,000. So that's, 45 plus 28, that's about 73. Um, that's about 73. And then 73 plus, let's say, 2, that's 75. And obviously, the 78 doesn't matter because that's a very small number compared to this. So we have 73 plus 2, 75,000. So now it says what percent? So what we have to do in such questions is just take the number of fellows because it says the number of fellows is approximately what percent of the total membership. So you take the number of fellows divided by the number of the total number in the org and times it by 100. So we are basically just doing 9,000 divided by 75,000 times 100 because both of these are in thousands. You don't need to include the thousand when you write the fraction. You can just call it 9 over 75. Um, a quick guesstimate, right? A quick guesstimate for you guys. You should know, of course, that 9 over 72, right? Because 72 goes into 9 is approximately 1 over 8, which is approximately 12.5%. So clearly 9 over 75 is a value that's slightly smaller than 12.5%, but not too small, not all the way up to 9%. Because if it were something like 9 over 99, or 1 over 11, that would be close to 9%. So your 9 over 75 is only going to be slightly less than 9 over 72, which is 12.5%. So your answer is 12% approximately. So this is how you can solve a question without having to use the calculator, just by using guesses, guessing through the numbers and doing calculated guesses. So that was the first one. So here's the next. It says in a recent election, James received 0.5% of the total 2000 votes cast. To win the election, a candidate needed to receive more than 50% of the votes. How many additional votes would James have needed to win the election? Okay. Well, essentially, he received just 0.5%. So 0.5% of 2000 votes. And he would need to receive more than 50% of the votes. So essentially, 50% of 2000 is obviously 1000. 50% of 2000 is 1000. And if you do 0.5% of 2000, the best way to calculate it is to first convert the percentage into a fraction by dividing by 100 and then timesing by 2000 because the off implies multiplication in percentage questions. So these two will cancel out. 0.5 times 20, that is 10. All right, so you would need, um, if you look at 1,000 minus 10, right, it's going to be 990. But remember, uh, if he gets an extra 990 votes, of course he will get a total of 1,000 votes. But that 1,000 vote would just be, exactly 50%. The question clearly says that to win the election, you need to receive more than 50% of the votes. So to get more than 50%, we are looking at any number that's more than 990, and therefore it's 991 or 1,001. And depending on yeah, if it says how many would be the least number of votes required in order for him to win the election, then your answer is 991. All right, so that's question number two. So here's question number three. This is on data sufficiency. So essentially, there'll be two sentences, right? This is a question. You'll have answers like this. Statement one alone is sufficient, but statement two alone is not sufficient. Statement two alone is sufficient, but statement one alone is not sufficient. Both together are sufficient, and each statement alone is sufficient. And both the statements together will not be sufficient. So that's how these questions are asked. So there are two people, Jim and Tom. And yeah, and the question is simply which one caught more fish? Well, it says Jim caught two-thirds as many fish as Tom. Look, let's say Tom caught T number of fish. It means that Jim caught two-thirds of that number. So Jim's will be two-thirds of Tom, right? No matter what, two-thirds of a number is always going to be less than the number itself. For example, if you take the number Tom as 30, right? Then your two-thirds of 30, it's a fraction. It's a fraction of 30. So it's automatically going to be less than 30. So that statement alone is enough to state the answer, In this case, with statement one alone, we can say that Jim has caught fewer fish or Tom has caught more fish. Okay, so that's your answer. Statement one alone is sufficient. Although we have to still check statement two. Yeah, let's take a look at statement two. Yes, after Tom stopped fishing, Jim continued to fish until he caught 12 fish. Yeah, I mean, this statement doesn't really tell us the number of fish that Tom has caught, right? It doesn't tell us anything. Tom could have caught fewer than 12 fish, or he could have caught more than 12 fish, right? So we know for a fact that Jim caught 12 fish, but the statement two alone doesn't say whether, Tom has caught more than 12 or less than 12. So we can't say anything based on statement two alone. Right. So the answer simply becomes statement one alone is sufficient, but statement two alone is not sufficient. So that takes care of this question. Let's take a look at another data sufficiency question. It says, how many of the boys in a group of 100 children have brown hair? So there's 100 children. Of the children in the group, 60% have brown hair. So let's take a look at statement one. Of the children in the group, 60% have brown hair, right? A quick check. 60% of these 100 children will basically mean that 60 children have brown hair, right? 60 children will have brown hair. But does that tell us the number of boys that have brown hair? No, it does not, right? Because these children could be distributed in any way between boys and girls, right? So basically, statement one alone is not enough for us to figure out the number of boys with brown hair. Now let's take a look at statement two. Of the children in the group, 40 are boys. Okay, of the children in the group. So we've got a total of 40 boys and 60 girls. That much we know. That's all we can figure out from statement two. Okay. So 40 boys, 60 girls. But do we have any information about brown hair in statement two? We do not. So we just know that there are 40 boys and the remaining 60 will have to be girls. So again, statement two alone is not enough to figure out the number of boys with brown hair. But what about statement one and statement two both together? Let's see. Well, 60 children have brown hair. And we know that we have 40 boys and 60 girls. But these 60 children with brown hair could be distributed in any way, right? It could be, you know, yeah, it could be like one boy with brown hair and 59 girls with brown hair. Or it could be two boys with brown hair and 58 girls with brown hair, right? We don't know the distribution. Yeah. So statements one and two together is also not enough for us to tell the number of boys with brown hair. So that's it. There's your answer. Answer option E. All right, let's take a look at the next question, guys. The remaining three that I have are just going to be normal quantitative reasoning questions. So let's take a look. It says Anish distributed 75 pencils to Ankan and Ankur. Okay, so there are two people, Ankur and Ankur, 75 pencils, and it says Ankur gets 1/7 more pencils. This is really important. Okay, so if it says Ankur gets 1/7 more pencils than Ankan, right? A good idea will be to take Ankan's to be X. Okay, and now take Ankur to be 1/7 more, meaning 1 plus 1/7 or 8/7 of X. That's the number of pencils that Ankur has got. Okay. And then these two together have to add up to give you 75 because these pencils are being distributed only to these two people. So now using your knowledge of fractions, you can combine these into one by just timesing this by 7 so that the denominators are the same. And when you do that, you will get 15x upon 7 is equal to 75. And a very quick way to get this done is to notice that, you would have, if the 15 were divided, it'll go into the denominator here. So instead of actually doing the division, you can just cancel 15 and 75 and make it 5. And then you get x/7 is 5. And if you want to solve for x, right, you can times both sides by 7, right? In which case the 7s will cross out. Or you can do something called cross multiplying. 7 times 5 is 35. So that's the answer. And that's the number that Ankan received, 35. All right. So that would have been my way of solving. In a natural lesson, depending on how the student is understanding, I would have chosen other methods to do it. But this method is more straightforward. All right, guys. So here's another one. This is a pretty common type of question. So they give you a weird symbol here, and there is a particular operation between x and y, and that gives you y cubed plus 3x. So here you would use BODMAS and first find 3 at 2. Okay. So 3 at 2 will simply be 2 cubed plus 3 times 3 because it is y cubed plus 3 times x. So whatever number is here is cubed. Whatever number is here is tripled, and you're adding those results. So in this case, this number is cubed, this number is tripled, and you add them. That is 8 plus 9, 17. So we now have in that bracket 17 at 1. 17 at 1. So let's see what this is. Well, it's the same rule again, right? You're going to take the latter number and cube it, and you're going to triple the former number, 17, and just add them. 1 cube is 1 times 1 times 1 is just 1. 3 times 17 is 51. So the answer is 52. There you go. That's your answer, guys. All right, moving on to the last one. This is a rather difficult question. I would call this very hard. Okay. So an integer n between 1 and 100, both inclusive. So between 1 and 100, both inclusive, will be chosen randomly what is the probability that n plus 1 times n plus 2 will be divisible by 4? First of all, if you choose from 1 to 100 including, that's a total of 100 numbers. Okay. So this is a probability question, and in your denominator, you'd have 100. Now we just need to figure out all the different cases where this product will be divisible by 4. So let's take a look. N plus 1 times n plus 2 is divisible by 4. Okay, let's see. First of all, let's start with the first number. Also, one more thing. It's important to notice that n plus 1 and n plus 2 are consecutive numbers. Okay. And if you look at consecutive numbers, then automatically one number has to be even and one number has to be odd. And it's pretty clear that the odd number is not going to be divisible by 4. So it has to be the even number that has to be divisible by 4. That's how you work this out. So if you try 1, for example, right, a quick check, right? Many people might do this, right? They might try 1. Quick mental check, right? 2 times 3, that is 6, not divisible, doesn't work. Let's try 2. If you try 2, you get 3 times 4. Yeah, so you get 3 times 4, which is 12, and 12 works, right? Now you may try 3. If you try 3, this is 4 times um, 4 times 5, right? So 4 times 5 is going to be 20. Let's see if any kind of pattern emerges. So that works. Let's try the number 4. This is going to be 5 times 6. That's 30. It doesn't work. Let's try the number 5. If you try 5, that's going to be 6 times 7. That's 42. That doesn't work. And if you try 6, it's definitely going to be 7 times 8. And 7 times 8 is most certainly going to work because 7 times 8 is 56. So 56 works. So we are pretty much looking at, we're trying to see if there's a pattern, right? Let's see if there is a particular pattern that emerges from this. Let's try 7 as well. If you try 7, you get 8 times 9. That's going to be 72. That most certainly works. Okay. And yeah, let's try 8. Okay. So if you try 8, it's going to be 9 times 10. That's 90. It doesn't work. So there seems to be a nice pattern emerging, right? The first and the last didn't work. The middle two worked. The first and the last didn't work. The middle two worked. It could be cyclic, of order 4, right? It could be repeating after every 4. That's definitely possible. Yeah, and that is also true because if you take 2, if you consider any group of 4 numbers, right? Without a doubt, one number is most certainly divisible by 4. But since we're dealing with 2 numbers over here, n plus 1 and n plus 2, in this case with n equal to 2, the n plus 2 gave 4. So that was divisible by 4. And if you try 3, the 3 plus 1 gave you 4. So that was divisible by 4. So it's pretty clear that in every set of 4 numbers, right? In every set of 4 numbers, you're going to have 2 numbers where the product n plus 1 times n plus 2 is divisible by 4. And how many such sets are going to be there? Well, it's going to start 1 to 4 and then 5 to 8, etc., etc. It's going to go all the way 97 to 100. Okay. So it doesn't matter that we count all these because of the symmetry, with every group of 4 numbers, 2 of them are going to be divisible. I mean, 2 of them are going to be such that the product is going to be divisible by 4. So that's all we need. So the answer is simply going to be 2 out of 4, which is 1/2. All right, guys. Thank you so much for watching. And I hope it made a lot of sense. And I hope to see you in my lessons. Thank you.